said that my broadcast has ended. Have I been banned from Twitch? Has Twitch decided to cancel me? Have I said the no words? Yeah, either way. Yeah, I just saved this as a chest. But I saved it wrong. Oh no. The shame. Either way, well, what I was saying is that when you save it, you can choose which category to save it in, and we're gonna save it as an object for now, because we want to make an object out of it. Cool, so now, since we actually created a object that we can use, we can go ahead and select our little object area right here, and spawn our chest right here. Looks about right. Check it out, there's little leaves around it as well. And yeah, so currently, my friend Seb just asked me how did I get so good at building shafts. Practice, bro, makes perfect. Alright, so what you see, this little golden ring right here. If I'm gonna go inside chest and click on behavior, I'm gonna see a little variable right here that's called FOV, field of view. And I can choose how big this is. Let's make it 3 for now. And what field of view is the distance to which our object is going to interact with other stuff. So let's say that an actor or an NPC walks into the range of this chest. And for some reason we decide that this chest is a mimic or, you know, a trap chest. And we want this chest to explode as soon as any human walks in its area. We'd select a FOV of 3 because we want it to explode when the actor is 3 meters or less away from the chest. And then we can go ahead and press edit script. And here we have a bunch of methods we can edit. And just as I said, the cool thing about it is that the engine manages when and how these methods are called, and all you have to do is just write the code that actually interests you. So what do I mean by that? Check it out. We have something called entities in proximity. Let's say we want to check whether there is any sounds or any particles for whatever reason. We want this chest to be scared of sounds, and we want it to walk away if there's any sounds. We would get all the entities, so sounds, objects, mapping objects, all this stuff, inside this method in the entities object, and we can check it out, like do we have any particles or do we have any sounds that are close to us, and we can kind of decide what to do based on that. And we have the same thing for actors, we have the same thing for getting the closest actor, and we also have something to this is something that gets called whenever your thing hits another thing, resolve collision, and it tells you what it hit as well. Here we could actually create our little gold coin explosion behavior if you'd like. So what we will have to do generally, but again, we're not gonna do it because we're lazy, you're just gonna have to trust me. What we will do is say other, and we're gonna check whether other is an actor. So we're gonna say something like other is actor, and then after we figure out that whatever touched us is an actor, what we can do is spawn a bunch of coins and perhaps destroy ourselves. Huh. I wonder if blueberry addiction is a thing. But for now, we're not going to do any of that, and we're just going to have some fun with physics. So I'm going to just save this, ignore it, and we're going to spawn another chest just on top of ours right here. And boom! Ha! Did you see that? They just kind of yeet around. I'm going to get rid of this real quick. And I'm actually going to add some collision to the walls as well, so we can have a bit more fun with physics. So I'm going to go ahead and let's see. This one is definitely blocked. So is this one. Yeah. Something like this, I guess. Yes, looks about right. Boop. Boop. You can see that the downfall, the downside of my collision system right here is the fact that it doesn't really handle diagonals all that well. You're gonna have to bootleg them like this. I guess it's good enough for our intents and purposes. It's not perfect, but I mean, you're not gonna be able to tell the difference really. Yeah, it's fine. Yeah, I guess we can do this as well. This. Yeah. Right, almost done. Yeah, I mean, this looks about right. And also what we're gonna do is we're going to do something like this. We're gonna enclose our area because yeah, we're not gonna really be making the entire map. We're just gonna make this little area right here, and we're also gonna spawn some actors, and we kind of want them to only be able to walk in this tiny area right here. And also have a surprise for you, so afterwards. But yeah, now when I try to spawn an object, a chest, on top of the other chest or of the wall, you can kind of see them just bouncing around. So that means that they have physics attached to them, which is kind of cool. But yeah, so all long story short, objects are mapping things, mapping sprites if you'd like, mapping renderables if you want to get fancy, that have a physics body as well as script attached to them. So we can go ahead and spawn one more just to have it there, like that, and we can go ahead and create the rest of the map. I actually don't know what arteries are, to be honest. Right, so for collisions, I actually don't do collision resolution by myself. Box2D kind of figures out what collisions to take into account. And the thing about Box2D, I kind of looked a bit into this. The way they do it, I think they have some sort of modified quadri algorithm. They kind of have, right, so I'm not going to get into a lecture right now, but quadris have this one weakness. You have to tell them how big they are and where they're placed. The way Box2D does, and they did it based on some research papers, some weird stuff like that, they managed to implement an algorithm that actually takes a quadri and makes it infinite. So you can have one object that's here, and you can have one object that's in Chicago, which is really far away, and you're still gonna be able to check for collisions. But the way I did it, oh, AABB, right? I don't really handle collisions by myself. But the thing that you saw on Twitter, the thing with the quadri, what I do is a reverse quadri type thing. So usually, what I used to do, my collision map, is made of these tiny squares. And before I asked you for your opinion on how I should actually implement this, and before I looked a bit into what I could actually do, I was pretty much just filling the entire map with tiny squares. And that kind of sucks because I think that Box2D already has a limit of like 1000 objects, so I was quite restricted in what I could do. So instead, what I do is, for quadris, you start with a big cell and you walk your way down, right? You create smaller and smaller cells for your objects. But with this thing, with a reverse quadri if you'd like, the purpose is the exact opposite. You're going to start with small cells, and what you're going to do is create bigger and bigger cells. So this one right here, it looks like it's a lot of squares across, but it actually gets merged into a single square. That's the only optimization I've done for collisions. I don't really take into account object versus object collisions, but that shouldn't really matter because I don't expect any game to have more than 1,000 objects at a scene. That's just nuts. You're not going to be able to interact with more than 1,000 objects a scene. So yeah, I didn't really bother looking into it too much. But if I'm proven wrong, and some madman actually goes ahead and uses this engine to create some sort of game like Noita, where you can just destroy everything, then I'm gonna stand corrected and optimize it. But yeah. Right, so now I'm gonna go ahead and showcase the actors. Right, so what we're gonna have here is an epic battle between two warriors, I guess. But before that, we're gonna leave the warrior bit at the very end. We're gonna look at the actors at the very end, and before that, we're gonna look into, let's say, 3 more things. They're gonna be short. So first of all, we're gonna look into lights. Let's go ahead and get rid of this thing right here, and we're gonna click on our scene. And when we do this, we can choose an ambient light for our scene right here. It's a bit confusing. Like, you look at this and you're saying like, yeah, dude, this is white light. Your current light is white. You can see everything. It's not really like that. Like Opacity lights doesn't work like that. And I'm trying to find a way to actually make it look and feel more natural. But the way this works is black light with full opacity means this. If we want to make the whole scene look darker, we're gonna still need all black, but we're gonna decrease the opacity. So this right here is gonna be a really dark scene. Like this. Cool. So it looks like it's night. So what we're gonna do is exactly what we expected. We're gonna place a light right here. We're gonna place one right here. And we're gonna place one right here. No, you know what? Scratch that. I'm just gonna keep one. This looks awful. I'm just gonna keep it like that. I think this looks better. It looks like a mysterious scene. It looks like one of those games in which you're fighting off thieves or walking down down dark alleyways. But the cool thing about it is that our lighting system uses the same colliders that we defined earlier. It also uses objects. It also makes use of the collider we defined earlier. I'm actually going to go ahead and create one tiny thing, just for the peace of my soul. I'm going to make something like, no. Right, and make this 0.3. Save. I'm going to copy it a bunch of times like that. Cool. And then do this. Right, copy this a bunch of times. Right, go on this layer right here, or right here. Are you seeing what I'm trying to do? I'm trying to make a candle. And this is probably the speed at which I'll be making assets. So you can kind of imagine the time you would spend for making an entire scene. It's definitely shorter than what you would do in Unity, in Blender. So there's that. Go ahead and select this. New. There you go. So now we have our little candle as well. Let's save this as candle. Right. So you can actually place this right here. use it as our little light source. Cool. And now we can go ahead and use a particle for this as well. And I'm actually going to show you something real cool. I'm using... Wait. I'm using a real cool program that's called Talos. What Talos is some dude that is only smart... Again, English blue screen on me. It's smart as hell. Like, this guy worked on libgdx, he worked on his own program. Actually don't remember what else he worked, but basically what he did, he created an entire node editor, like the one you would see in Unreal, and ported it for libgdx, so you can use that as your particle editor. Let me show you real quick. Let me save this again just to make sure. So you can have something like, so you have this little program right here, right? And you can add nodes and stuff and create your particle effect that way. For instance, let's take some fire. And you can create some really complex stuff. And I'm currently using this guy's system in order to add particles to my engine. But the cool thing about it is that he made the entire thing open source. And this entire thing is made in the same thing I'm using for my engine. Which means, if you catch my drift, I can possibly integrate this thing into Behemoth. So maybe if everything is cool, I'm going to be able to allow you to edit your particle effects inside the engine without having to open a different application, pretty much. But without further ado, the reason I'm hyping this up so much is because, yeah, the fire effect is cool, and you're going to see it in the engine as well. But you can make something that's so much cooler. You're going to see in just one sec. Right, so let's just drop our little particle right here. It's called Fire2. And yeah, it's there, but I'm going to have to raise it up a bit. I think it's that's way too high up, like 2 meters. That's still way too high up. 1 meter. It's like 0.8, I think. Kind of. Yeah. I'll be honest, like, this sucks. Trying to play with particles kind of sucks, but it kind of looks like it should be like 2.0. Actually, wait, what the fuck am I doing, dude? I'm just gonna look at here. I'm gonna say make it 11.0 and 3, minus 3. Go ahead and do the same. 11.0 and minus 3. Right. Right, and now all I have to do is just increase the elevation. I'm gonna make it 2. 2.2. 2.4. There you go. And our little candle has the particle effect attached to it. It's a bit slow when it's moving around, so it kind of looks like it's lagging behind. Well, I mean, I guess you could like that effect. It leaves a bit of a trail. But yeah, the other particle effect I want to showcase is, so you have decent particle effects, right? You have sprite-based particle effects. You've seen this a million times. This guy, the madman, has actually created beam-based particle effects. Check it out. Make this bigger. It's 5. How freaking cool does this look? Like, look. Mate, this looks amazing in my opinion. Can you believe that this is done with particles? How about... Bruh! And this is just something I made with knowing close to nothing about the program. Like, this guy makes full-fledged, I wouldn't say AA, AAA type studio looking particle effects, but it does look like one of those things you would see in really polished indie games. And the thing is, he can use smart stuff such as like purling noise and stuff to deform the particle effect. But yeah, either way. Now, for the last thing before we get to our actors, you might remember how at the very beginning of this stream we dragged a bunch of files into a folder. We dragged a bunch of textures into a folder that's called textures. That's because of this. We have scripts. We have a proximity script, which is fairly self-explanatory. It can take care of, it does stuff with stuff that comes close to it. So you would use this, for instance, for programming a door. What would you do when NPC goes close to a door? You would teleport it to another scene. Or what would you do if an effect, bruh, I'm getting tired. If an actor gets too close to a fire, he would lose health and, catch fire. So this is what you would use proximity scripts for. And that's, fair enough, expected that. But, and this is the thing I'm really excited about, and it might be just me getting nerded out. Like, it might be just me getting hyped for nothing. But, add the render script. Once you add the render script, you can go ahead and edit it. And you have complete control over the rendering pipeline. What does this mean? Usually, with Unity and to be completely honest, I only have experience with Unity and RPG Maker, so that's kind of my palette of what I can talk about. But usually what Unity does, I guess, it lets you paint stuff on screen by dragging objects around. So you can click and drop a cube on the map and it gets painted on the map, right? But at no point, as far as I know, does Unity allow you to actually draw pixels directly to the screen in the same way that the engine would. Well, I give you access to the exact same pipeline I'm using to draw all the stuff on my game. The stuff that I'm using to draw my HUD and the stuff I'm using to draw every single layer of the sprites, all that thing, you have access to it. You can use the textures that you put inside the textures folder, draw them on the screen. You can use debug renderers. You can draw lines, you can draw circles on the scene, but you can also draw them on the actual screen. So you can make stuff like buttons. Let's say you want a, fuck it, I'm just gonna show you. Let's create a new render script for showing a one of those World of Warcraft looking exclamation marks for when you get a quest. And let's make it go up and down, because why not? I'm gonna go ahead and say something like this. First of all, we're gonna need the sprite. I'm gonna say var quest. I'm gonna say assets that create sprite, and we're gonna use the name of a texture that we dropped in the textures folder, which in our case is quest. You can't use extensions. This is a limitation of the engine. You're just gonna have to say quest instead of quest.png. That means you can't have the same thing. You can't have quest.png and quest.jpg in the same folder. But yeah, and then we're gonna set its position, let's say, to 0, 0. Right. Let's put it somewhere here. So that would be like 5 and -3, let's say. Like that. I'm gonna say quest.set position 5 -3. Easy peasy. And I'm also gonna say quest.set size. I'm gonna make it a bit smaller than it is because right now it's huge. I'm gonna make it 4 by 16. Cool. And I'm gonna render it on the scene. So that means I'm gonna render it in the coordinates that we use to draw our stacked sprites and stuff. So we're gonna go ahead and use this object right here called a renderer. And we're gonna say render. Oh, by the way, you also have auto completion, but it doesn't really work. So you have stuff like this. But I still have to set it up for my own methods. And we're gonna go ahead and say quest. Now in theory, if I didn't mess anything up, I didn't, did I? Oh yeah, I didn't. It just drove it all the way over here. All right, let's. That's very far away. I have no idea why it got drawn here. Let's say 0, 0. I should have no idea what's drawn here. Oh, wait a second. Oh, yeah. Sorry, friends. It seems that I have a bug. I have the first bug in my game. Yeah, I'm probably not gonna be able to render this at the right position because apparently it doesn't take into account the size of the actual damn thing. So it's gonna paint it all the way over here when it's supposed to be painted here. But yeah, I'm not gonna waste too much time with this either. But you can draw random stuff on screen. You can draw custom stuff on screen. So if your NPC has a quest for you, you can just draw the quest indicator. And you can also draw stuff like circles and whatnot, other stuff. So I'm gonna go ahead and get rid of this render script, and I might do a separate showcase for what you can do with this, because you can make buttons, you can like make them clickable, but yeah, it's not exactly interesting for this stream. Either way, so next, I'm gonna go ahead and show you some actors. I was trying to make it sound good. Don't judge me, okay? But yeah. Oh, thanks, man. I'm actually very glad that you're actually into this kind of thing. I was actually thinking it's just dumb little thing, but it was easy to add. But I'm glad that other people seem to find it useful as well. But yeah, so actors. I'm gonna go ahead and spawn a blank actor. Boom. You can see it gets affected by shadows as well. But you see it has a bunch of tiny dots and a little head right here. The thing about these tiny dots is that once I click on him and select display, you can see a bunch of joints, or rather areas, and buttons. And the thing about it is that as soon as you press one of these buttons, you can assign any stacked sprite to any joint. And that means that whenever our actor is moving around, that little thing is moving around as well. Which means that we can create custom actors just by binding different stacked sprites to different body parts. It's very similar to how you manage to bind sprites to joints, not joints, to bones in your animation thing. Gizmo, by the way. Yeah, there you go. So I'm not going to spend too much time on this because, in all honesty, I haven't really tried out the artistic side of it. So I'm not exactly sure how to make stuff look good. So instead, I'm just gonna make something just for debug purposes, and you'll see what I mean in just one sec. I'm gonna make two things. First of all, I'm gonna create a little. Let me find out. I'm gonna create a little sprite for our joints. So for our ankles, for our elbows, shoulders, knees and toes, head, stuff like that. And this one is gonna be a tiny square. What? Apparently it's there, but I just can't see it. What? Oh, dude, I think I know what's going on. Yeah, apparently my transparency is getting leaked. Wait, you're gonna see what I mean. I'm gonna go ahead and save this real quick. Oh, dude, no, wait. I think I know what's going on, but let me restart real quick. That's a bug where for some reason the transparency of our colors gets carried away to our object editor and everything just kind of looks transparent as fuck, basically. Right, so, bro. Oh, come on. I really hope my my save file didn't just shard and... Bro, no! Oh, for fuck's sake. Yeah, I know what's going on. Don't worry. It will be an easy fix. Talos, particle source component. Or maybe not. Oh, wow. Right, whatever. I'm not even going to attempt to fix this. Basically, I added in the particle effects just before starting the stream, and I fucked it up. So when I tried to save the particle effects, it pretty much corrupted the program, and I actually have to take care of that. Yeah, the pleasures of early alphas. Yeah, I'm sorry for that, guys. I'm still gonna show you what actors do, but we're not gonna really have a fight scene. We're not gonna have a cool looking backdrop for it. But yeah, whatever, I guess. I'm gonna make a short Twitter video with it, and you can just pretend you saw it on the stream, whatever. But yeah. Yeah, so as I was saying, we were making joints, right? Let's create a super small joint right here, and we're gonna make this a 0.2, copy it a bunch of times, and this would be what we would use as ankles or shoulders or whatever. Let's say a joint. And we're gonna save it as an actor. It's not an actor, it's something we would use for actors. So we save it there. And something else we would need is bones. So what bones are is what we would use to construct stuff as forearms and arms, legs, stuff like that. So stuff that has a length and goes down. Explanation of the year right there. So we're just gonna make the exact same thing, but just a bit longer. Make this a 0.3. And there you go, we have some massive looking legs. Fair enough. We can save this as bone. Right. So now we actually create an actor. Let's make the same hack thing we did. Make a little arena right here. And we can go ahead and spawn an actor. And just to go real quick through the whole concept of this, I'm gonna go ahead and select bones for all of this. I'm gonna make his head look red. I'm gonna skip the neck actually. I'm gonna add the shoulders, left shoulder as well. I'm gonna add the right arm, which is gonna be a bone. Left arm is going to be a bone as well. Elbows are going to be joints. What? Yeah, elbows are going to be joints. Dude, what? Oh, I think it's the exact same the other way around. It's supposed to say edit for things you picked and pick for things you didn't pick. Ah, whatever. I'm gonna pick a bone for this one as well. It's getting me kind of confused, I'm not gonna lie. Right hand is gonna be a joint. Joint. Torso is gonna also be a joint. Pelvis is gonna be a joint. Robe we're not gonna touch. Right leg is gonna be a joint. Left leg is gonna be a joint. Foot is gonna be a joint. Yeah, I completely messed up the explanation. Let's see. Yeah, I know, dude. I know, it's a pain. I know. But yeah, Yeah, so what currently happened right now is that I made my hands way too large. And because of that, my my actor looks like a mutant. But yeah. Yeah. You know what? I'm actually not going to ruin the concept of this. And I'm probably just gonna make a new stream or a new clip or something when that actually looks nice. And I'm just gonna end it on a semi-high note, I guess, where I'm just gonna show you how you can make actors kind of fight with each other and kind of give them some sort of AI. And I'm just gonna end it on that note. So for now, what we're gonna do is let's get rid of this as well. And we can go ahead and create some variables. Why? Because how are actors going to be able to tell whether they're enemies or not? We're going to create a variable to take care of that. We're going to create something like faction. And we can go ahead and create a new variable, which is going to be called faction. This is going to be a string. It can also be an enum, but we're not going to get too deep into it. And based on whether this one is equal or not between units, we're going to decide whether they're enemies or not. So the type is going to be a string. Again, it can be a number, a boolean object, or an enum, but we're just going to keep it a string for now. The scope is going to be entity, so we want entities to have it. We're not going to apply it to all classes because we don't care for mapping, having factions or objects or anything like that. We just want actors to have it. And the default value is just going to be red for a red faction. Right, so if we're going to place a actor here, we can check it out and we can see that it has red faction. And we can place another one and can go ahead, it still has red faction, but we're going to change this to blue. Right, so now in theory they're enemies. So now if we go ahead and check this guy's behavior out, we are going to see a method here that's called isEnemy. And what isEnemy does, it tells the engine, like the guts of the actual system, how it should sort, how it should use quad trees, and how it should call the other method in the script in such a way where it actually gets to differentiate between different actors and be able to tell whether something's an enemy or not, pretty much. So in our case, what we're going to do is say the other actor, that get, which is pretty much getting a variable from that actor, which in our case is called faction, is not the same as our actor, which is an actor with a capital A, that get faction. So what I'm trying to say now is if our faction is not the same as the whatever other guy's faction is, then that guy is an enemy. Right, so now we decided that that guy is an enemy. What do we do once we see that we have an enemy around us? We can do a bunch of stuff. We can shoot arrows at him by spawning templates we saved. We can do pretty much whatever. I mean, yeah, we can spawn objects that have their own scripts, so he can make spells, and we can throw eggs at him that hatch into dinosaurs while they actually hit the target. We're pretty flexible with what we can do. But since I have to end this quite soon, I'm just going to go ahead and edit this closest enemy method right here and say the following thing. I'm going to say if closest enemy is not null, like that. So what I'm saying is that there is a close enemy close to me. I'm just going to go close to him. I'm going to say actor dot set movement seek. So I'm going to seek the closest enemy. And I'm also going to check a different thing. I'm going to say if the distance, which is this thing right here, is smaller than, let's say, 1, I'm going to go ahead and say closest enemy dot destroy. And this pretty much removes it from the game altogether. So now if we run this, we can see the guy actually got triggered and he's going towards the enemy. And once he reaches him, oh come on, he's getting derailed because of the physics, buddy. There you go. Once he gets close enough, he destroyed the other guy. And you can use these systems to create a bunch of different behaviors and stuff. What I managed to add before this was a system where a guy was shooting arrows that would seek the enemies. But I'm pretty sure that while it's going to get a bit more polished, you're going to be able to add more complex behavior as well. But yeah, before I go, I'm just going to showcase one last thing, which kind of ties in what I showed you here. Let's say that we want to have an actor that just walks around, does nothing else. He just walks around. I'm going to say set movement wander. Like that. Cool. He's just chilling. But we want to have a bunch of these actors that walk around, and we don't want to have to do this individually for all of them. And this kind of ties in what we were talking about at the beginning of the stream with prefabs. The way you would do this is you would select the root element right here, and this works for sounds. This pretty much works for any type of entity. Lights, particles, mapping, anything. And you can select the root object right here, and you can go ahead and say save template. And I can say walking homie. I'm going to save it, and I'm going to save it here. And you can see it. You can see a little number in between brackets, and I can actually use this thing in order to identify it. And once identified, this is pretty much an ID, I can actually spawn it from scripts as well. So I can do something crazy, such as I can edit my first guy right here, and I can say something like this. I say var x equals 0, and I'm going to use this as a tick, right? And say x++. So every single frame, I'm going to increase that x, because this logic function right here just gets called every single frame. And I'm going to say something like if x is bigger than, let's say, 200. First of all, I'm going to reset x, and then I'm going to say global.spawn 1, because remember, the ID of our template is 1. And what I'm going to do is I'm going to spawn it right next to our spawner actor, right next to the current actor. So what this would do is every 200 ticks, or let's make it more like 100 so it's quicker, this guy is going to spawn another guy that's walking around. It doesn't exactly work like prefabs. Like if I change one guy, the other guys are not going to get changed automatically. They're separate instances, but they're pretty much templates that I can also use inside scripts, and I think that's very useful for making stuff like projectiles, and of course for making stuff you can reuse as well. But if we save this and look at our little guy, should in theory spawn him. Did I mess something up? X++. Is it not global? Wait. Just give me a second. Global scripting interface. Spawn, right? Yeah. Yeah, I must be missing something. Oh, wait. I think this is why. Maybe? Okay, apparently not. Right, I'm not entirely sure why this doesn't work. Whatever. I think I'm just gonna do a final thing when I'm gonna make a our little guy just say something. I'm just gonna make him say actor that say sorry. I am not sure why this stuff isn't working. I swear it was at some point. Right. And I'm just gonna have him say that. Yeah, but in theory, what should have happened is that another actor should have spawned from the origin of this guy. Again, not sure why, but it doesn't work. Either way, that is true. That is true. I have something like that. I have a debug log. It's all right. Check it out. It's not very powerful yet, but I have something called console.log, and I can say hello world. Oops. And check it out. I'm gonna get it right here. And this stuff is pretty useful for debugging as well. I can also write the whole thing red. But yeah, yeah. Anyways, guys, thank you so much for joining me for this lengthy adventure filled with a lot of fun, in my opinion. It was actually super fun having all of you guys here. Thank you, man. Thank you. I really appreciate the feedback. And what my plan is, I made a few Trello boards, and I think it should be done in about 3 months. And what I mean by that is that you should be actually able to create runnable games with it in about 3 months. But yeah, until then, I have to figure out how to fix the bugs, and I also have a few more cool plans. One where I want to be able to edit actual skeletons in the game, so you can make custom skeletons like dogs and centaurs and spiders and whatnot. And I also want the UI editor where you can actually place buttons on the screen and make your own user interfaces. Because right now, if you want to make something like a inventory system, inventory. If you want to make an inventory system with the tools you have so far, good luck with that. So probably need a proper UI editor as well. But in the meantime, guys, thank you so much for joining me, and thank you for staying through. I think it must be at least 1 hour. It's like 2 hours and a half. Holy shit! Thank you very much for sticking around for 2 hours and a half. And I'll see you guys around. I am off to eat my blueberries and play some Noita. See you guys. Have a nice one.